All right, so we have two more talks ahead, and the next is gonna be pre-recorded. So this topic, we're gonna talk more about MVVM. The topic is Android MVVM project template. The presenter is Ali Ahmed, who is a developer from company VoxSmart. So let's start the video.
Hi, welcome to the Android Development Global Summit by Geekle. Hopefully, you are enjoying every session and you are learning a lot. I'm Ali Ahmed. I'm gonna share Android MVVM project template. Basically, I have splitted the overall session in different parts. Firstly, I'm gonna share my screen to discuss MVVM overview with the MVVM components. And then I will share a code base. I will not write any inline coding, but I will share a code base so that you can get a clear idea how MVVM project look like. After I will discuss the comparative studies of MVVM and MVP. In our session, if you have any question, please write it down. I will try to give a proper answer. After the summit, if you have any queries regarding the Android development, you can contact with me using my mail or my social media. I will share those details later. Welcome to my session and thank you for joining with me. Now I'm gonna share my screen. Here, my topic is Android MVVM project templates. This is about me. I have 5+ years of experience in Android development. Currently, I'm working as an Android developer at Voxmart. Previously, I worked for several organizations like banking sector, telecommunication sector, and software firm. Yeah, in my additional time, I really enjoy playing cricket or watching cricket. Now I'm going to discuss why a boilerplate or template is important. Like when you start a project, it's important to choose an appropriate architecture where the project will be grown. Like we need to add some modules in future or feature, or we need to enhance some change requests. So if we don't follow a proper architecture, then it will really difficult to manage the overall code base. The benefit to having a boilerplate or templates. A boilerplate includes all tools required for the development of full-fledged apps. It really helps to organize the project skeleton, and the development speed is faster than the traditional development. The project template designed with UI, dependency injections, network calling, local storage management, so we don't need to think about the starter code. Okay, the available architecture or boilerplates are MVVM, which is known as model view model, MVP, model view presenter, or recently Google has introduced Android clean architecture. As my topics is MVVM project templates, so I need to discuss regarding the more about MVVM, like what MVVM really is and what are the components of MVVM. So here you can see the high level view of MVVM, where view is mainly represent the user interface. It will not process anything, or in view you can't write any business logic or presentation logic. And model is represent the business logic. Basically, models collect the data from different data sources and it process the data according to the business logic and provides the data to the view model. View model mainly observe the data from model and it's perform the presentation logic. After the performing presentation logic, it provides the data to view. Here is the MVVM responsibility chart. Like view is responsible for the data visualization and observe the view model. And model holds the data of the application and act as a gateway to the business logic. And tools of data processing, like it will collect data from different data sources. And data sources can be API or local storage. So basically, model will collect data from those data sources and it will process the data according to the business logic and provide those data to view model. And view model mainly link between view and view model. View model observe the data from model and deliver the data to the view. So basically, it's prepared the observable data. Consists of all information that requires to the display the view. As I said, view model perform the presentation logic like how data needed to be shown. So it will process those things. And multiple view can share a single view model using shared view model. This diagram is low-level view of MVVM, or you can say this is the Android specific diagram where view contains the UI elements. It can be activities or fragments. So from view send the UI event to view model, and view model send the request to the model. And you can see this is the more splitted diagram of model, and here the repository is there. What is repository? Repository mainly communicate with the data sources. So data sources can be remote data sources or local data sources. So we can say repository mainly power from the network call to collect the data from remote data source, as well as it can power from the local queries to collect the data from local storage like SQLite. And after collecting the data, it changes the callbacks. So view model can observe the change, as well as it can send the data to the view after performing the presentation logic, and accordingly view can update the UI. Now question is how we can achieve this overall scenario. For that, we need to take help from some other components. What are they? These are dependency injection. Basically, we need to provide runtime dependency in any object. For that, we can use Kotlin Koin, heal, trigger. We need observer patterns because, as we saw, view is observing view model for data, and view model also observing the repository for callbacks. So we need observer patterns. For that, we can use Kotlin Flows, live data, and we need concurrency, which is we need to perform multiple tasks at a time so that our application will be more efficient. For that, we can use Kotlin Coroutine RX Java. Also, we need data binding. What data binding really is? The data binding is a support library that allows us to bind UI components in our layouts to data sources in our app using a declarative formats rather than programmatically. And obviously, we need to generate view. For that, we can use Jetpack Compose XML. Now we will see more details regarding the components dependency injection, observer, and concurrency. Okay, dependency injection is a programming technique that makes a class independent of its dependence. Basically, dependency injection is passing the dependency to other object or framework. For example, consider a car object. A car is depends on wheel, engine, fuel to run. Traditionally, we need to define the brand of such dependent objects along with the definition of the car objects. So basically, car is responsible for creating the dependencies. So what if we want to change any dependencies on the runtime? So we need to recreate the car object. So then what does the dependency injection do for us? While using dependency injection, objects are given their dependencies at the runtime rather than the compile time, so that we can change any dependencies whenever we want. The advantages are dependency injection reduces the boilerplate code. It makes our code more reusable and clean. And it makes easy to replace our dependencies with fake implementation, which make testing easier. For example, we want to use mock of wheel during test instead of a real instance. We can create mock wheel object and let dependency injection inject to the car. And it helps us to enable the loose coupling. And for this boilerplate, I'm going to use Kotlin Koin for dependency injection. What is Kotlin Koin? Koin is a dependency injection framework for Kotlin developer. It's completely written in Kotlin. It is very lightweighted. It is one of the easy dependency injection framework which doesn't require a steep learning curve to get hold of it. Understanding the terminologies in Koin. While we are working in Kotlin Koin, there are few terminologies we need to understand before we getting started. What are the module? Basically, it creates a module in Koin which would be used by Koin to provide all the dependencies. Single. It creates a singleton that can be used across the app as a single instance. For example, in car object, when we use single for injected fuel dependency, so basically in across the application, it will create only single instance. And factory, it provides a bin definition which creates a new instance each time it is injected. Basically, it's opposite of single. For example, in the car object, we need to provide the dependency of wheel using factory so that every time while car will take the dependency of wheel, it will create new instance of wheel. Get, it is used in the constructor of a class to provide the required dependencies. Okay, now we need to know how to use Kotlin Koin in our Android project. For that, we need to implement Kotlin Koin core and Koin Android dependencies in build.gradle file. And from application class, we can start Koin using the start Koin keyword. In the block of start Koin, we can add multiple modules. For example, in our application, we are using a remote source for fetching data so that we can provide the network module dependency to view model. For that, we can create network module and provide dependency in using the app module. Basically, app module provide the dependency of network module to view model. Using the single keyword, actually it provides only single instance across the application of network module. So using the get keyword, view model will get the network module dependency from app module. That way, we can provide the dependency of network module in an MVVM project template. Concurrency is one of the most important component. What concurrency actually is? Concurrency means multiple computations are happening at the same time. Concurrency is everywhere in modern programming. In fact, concurrency is essential in modern programming. So whether we like it or not, multiple computers in a network, multiple applications running in one computer, multiple processor in computer. So actually we can say concurrency is essential in modern programming. Example can be website must handle multiple simultaneous users. Mobile apps need to do all their processing on server as well as need some processing in device logic. In that case, concurrency is required. In graphical user interface, almost always require background work that doesn't interrupt the user. In mobile apps, user can place network request and scrolling a list. So in that case, the concurrent task is happening. So user shouldn't impact because of the concurrent task. The benefit of concurrency is that design pattern we can use on Android to simplify code that execute asynchronously. Multiple worker perform multiple tasks at a time, reduce the workload of main thread, completely vanished Android not responding related errors. So in our boilerplate, I will use Kotlin Coroutine for achieve this concurrency. According to the Google, over 50% of professional developers who use Kotlin Coroutine have reported seeing increased their productivity. Now we're gonna discuss Kotlin Coroutine. Coroutines is a recommended solution for asynchronous programming on Android. The main Kotlin Coroutine features are it's lightweight. We can run many coroutines on a single thread due to support for suspension, which doesn't block the thread where the coroutine is running. Suspending saves the memory over blocking while supporting many concurrent operations. Kotlin has fewer memory leaks. So if we use the structure concurrency to run the operation within a scope, then we can achieve that one. So we need to know which scope we need to use. So I will discuss furthermore about the scope. Kotlin has built-in cancellation support. Cancellation is propagated automatically through the running Kotlin hierarchy. Like if a task is, if a Kotlin task is running parallelly and the application is killed, then the task or the in processing Kotlin task also be killed. So it has the cancellation support. Kotlin Coroutine has Jetpack integration. Many Jetpack libraries include extensions that provide the Kotlin full support. Some libraries also have provided their own coding scope that you can use for structured concurrency. This is how Kotlin Coroutine looks like. In that way, we can launch any coroutine task. So it has four parts mainly: coroutine scope, coroutine context, coroutine builder, and coroutine body. In coroutine body, we can add any suspending or regular function. In Kotlin has different scope, as well as we need to pass a different Kotlin context. And it has three Kotlin builder. launch, async, and await. So basically now we'll discuss Kotlin scope. Kotlin has different scope. One of the most important scope is global scope. The maximum lifetime is equal to the lifetime of the application. If the coroutine finishes its job, it will be destroyed and will not keep alive until the application dies. But let's imagine a situation when the coroutine has some works or some instruction left to do, and suddenly we end the application. Then the coroutines will also die. As the maximum lifetime of the coroutine global scope is equal to the lifetime of the application. And the scope is lifecycle scope, which is pretty much similar to the global scope, but it has only difference that when we use the lifecycle scope, all the coroutines launched within the activity also dies when the activity dies. It is beneficial as our coroutines will not keep running even after our activities dies. So its lifecycle scope is lifecycle ever, and it depends on lifetime of a lifecycle of an activity. V model scope. So V model scope will live as long as the V model is alive. So in coroutine scope, we need to provide the coroutine context. Coroutine context defines the threading policy, exception handler, control the lifetime of the coroutine. And there are three most important coroutine context. One is dispatcher, coroutine exception handler, and the job. Dispatchers defines which thread runs the coroutine. A coroutine can switch dispatcher anytime. So mainly there are three dispatcher, dispatcher.default, dispatcher.io, and dispatcher.main. So dispatcher.default uses a shared background pool of thread. By default, the maximum number of threads used by the dispatcher is equal to the number of CPU cores, but it at least two. And dispatcher.io mainly shares the threads with dispatcher.default, but number of threads is limited by the Kotlin parallelism. And another one is the dispatcher.main. It's equal to the Android main thread. And there are other sub dispatcher like dispatcher.unconfined, a coroutine dispatcher that is not confined in any specific thread. The coroutine execute in the current thread and first, and lets the coroutine resume that whatever thread that is used by the corresponding suspending function. Now coroutine builders. Coroutine builders is two things like launch and async. As we saw that we can launch a coroutine. So there's a this called the coroutine builders. Launches a new coroutine without blocking the current thread and returns the reference to the coroutine as a job. And we can also add async instead of launch. Async creates the coroutine and returns its future result as an implementation of deferred, which is non-blocking and cancelable future. Another most important components of MVVM is observer pattern. Observer pattern defines a one-to-many dependencies between objects so that one object changes state, all of its dependencies are notified and updated automatically. Basically, observer is a behavioral design pattern. It specifies the communication between the objects. Two things, observable and observers. An observable is an object which notifies observers about the changes in its state. For example, a news agency can notify channels when it receives news. Receiving news is what changes the state of the news agency and it causes the channels to be notified. In our MVVM diagram, we can see view is observing data from view model and view model is observing from model. So in that case, we need the observer pattern. So basically, subject changed, like multiple observer will notify the updates. So to achieve that, we can use Kotlin Flow or Live Data or RX Java. In that case, in this boilerplate, I will choose Kotlin Flow. Now I will gonna discuss Kotlin Flows. Using Kotlin Flows, how we can achieve observer patterns. Basically, flows are built on top of coroutines and can provide multiple values. A flow is a conceptually a stream of data that can be computed asynchronously. And flow is a Kotlin type that can be used model stream of data, just like live data and RX Java stream. Flow lets you implement the observer patterns, a software design pattern that consists of an object, which are observable, producer, source, or emitter, that maintains a list of dependencies called observers, subscribers, collectors, receipts, and notify them automatically of any state change. So to generate data and consume data, we need two parties like producer and consumer. A producer produces the data that is added to the stream. Thanks to Coroutine, flows can also produce data asynchronously. And consumer obviously consume the value from the stream. An optional intermediary can be there who can actually modify each value emitted into the stream or the stream itself. Now we are gonna see in Kotlin Flows how producer produce data and consumer actually consume the data. Here is a function who is acting like a producer who is producing the data and emit the data to the data stream. And consumer one basically it collecting data from the data stream or producer, as well as consumer two also doing same thing. So basically this is the producing data, and consumer one and consumer two consume the data using flow. Now, some other terminal operations includes like to collection, first and last, single, reduce or fold are there. So as I said earlier, basically using the collect keywords, Kotlin flows collecting data from the producer. So other operations are there, like two collections. It collects the flow into the provided mutable collections, and first and last return the respective elements of such element exception. There are also variants that taken predicates as an arguments or return null instead, throwing an exception. Single. Single is AOS for just one value to be emitted and can throw. As well as reduce and fold there can be used to reduce a flow to a single value. That's all from theoretical part. Actually, in that part, I tried to describe the MVVM overview and the every components how they work each other with help of other components like dependency injection, concurrency, and observer patterns. For that, I tried to dig down little bit Kotlin flows, Kotlin coroutines, and Kotlin coins. So now I'm inviting you to see the practical implementation. I will share a code base with you. Okay, for practical implementation, I have prepared a sample MVVM project where I try to touch every MVVM components, and I named this application as a news app, while list of news will generate it, and while you will press any item, then you will see the details view of news. It's a really simple application. For fetching news list, I am using an open API which is known as News API, and I have uploaded the overall project in GitHub, so anytime you can download to check how my MVVM projects look like. And I will manage this repository over the time, so we will get the up-to-date code base. The tool I have used for this project, obviously I am following the MVVM architecture. The programming language I am following Kotlin. I have used Kotlin Coroutine, Koin, Navigation UI, Kotlin Flows, and retrofit for network calling. Now I'm gonna share my code base. I hope my ID is visible to you. Here is the basic project setup. I have enabled the internet connectivity, and for Gradle dependencies, I am using Koin Core, and Koin Android for dependency injection. For network calling, I am using retrofit 2, OKHTTP, and JSON for JSON converter. And as I am using view model and plus lifecycle, so obviously I need lifecycle at runtime. And for coroutine, I am implemented the Kotlin Android and Kotlin Cores, and other supplementary dependencies are there. And I have introduced some build types like release build types, debug, and staging, where you can use the base URL according to the build types. And you can add other dynamic variables. Also, you can introduce product flavor if you need. So this is the basic project setup. Here is the project structure look like. The different directory contains the different responsible classes, where the DI directory will contains the classes that represent or responsible for the dependency injection. The model directory will contain the classes which represents the data structure. Network directory represents the classes responsible for interacting with API. And UI is the directory is responsible for the view classes. And repository, obviously, it will communicate to the data sources to fetch the data. And view model contains the view model classes who will communicate with repository and also with the view. Let's start with the model. Basically, model is representation of the data received from the API. So now, have a look. What is the response we are getting from the API? Basically, this is the main response we are getting from the API, and this is the JSON array, which is known as articles. Basically, this is the main news list. So we will generate this list in our application using recycler view. And firstly, we need to prepare the data classes according to the JSON object and JSON array. So here is the main response. You can see the article data classes is generated according to the JSON object. Note that I used an annotation which is serialized name. So serialized name indicates that the property should be serialized with the specified name. Basically, this will be used the JSON converter at the moment of decoding and encoding the data. Let's start with view. In our overall application, there is only one activity, which is main activity. So main activity contains a drawer layout, a bottom navigation menu, and a fragment container. So here is the fragment container. There is the bottom navigation view. So as we are using the navigation, here is the main navigation graph where two fragments are available. One is news fragment, another one is details fragment. And it's connected in fragment container. So here it's connected to the main activity. So according to the bottom navigation menu, it changes the fragment. So one fragment is news fragment. Basically, news fragment has a recycler view, and recycler view will generate the news list. For that, news fragment will communicate with the news view model, and news view model will communicate to the data repository. Data repository perform the network call, and that way the news list will be generated. Now I'm going to discuss regarding the network module. So for network calling, we need a base URL, and base URL is stored in Gradle file in build types. So base URL can be changed according to the build types. So as I'm using the retrofit for network calling, so API client is generating the retrofit builder, and API service interface contains the endpoint of the API. And basically, data repository hit this endpoint, and it will return the news main response. And data repository sends the data to the news view model. So in response model class, I have defined some states which are success, error, loading, and idle. So according to this stage, news view model can detect that the response is successful or not. Let's talk about the dependency injection. As you know that we are using Kotlin Koin as a dependency injection framework. So we need to start Koin in the beginning of the application. So from main application, we are starting the Koin, and we have only one module, which is app module. Actually, app module is providing the all dependency across the application. As you can see, news view model requires the data repository dependency, and data repository requires the network module. So actually, app module provide the all dependencies. So while any class call the news view model, that class don't need to create the data repository object because Koin is providing this dependency automatically. Let's see, news fragment is calling the news view model, but it is not providing any data repository object as the Koin is prepared the data repository object explicitly. So that way we can use dependency injection over the application. In our application, news fragment as a view need to generate a list according to the API response. For that, news fragment solely relying on news view model, and news view model will call the data repository for the latest news. And data repository will call remote data sources for the latest API response. As long as it gets the API response, it will emit the response using Kotlin Flows. And NewsBay model will collect this response immediately, and it will decide that data response is successful or failure. In both states, it will emit the response result to the news fragment, and news fragment will handle data accordingly. If the response model is error, then it will show an error message. Otherwise, it will generate a news list using the news list adapter to recycler view. In that way, the whole communication is going on. So using Kotlin Flows, we're observing data in news fragment, in newsview model, and the data repository. And using Kotlin Coroutine, we're performing this concurrent task. So that way, the smooth communication is going on. Hopefully, you have got a clear idea MVVM project implementation practically. For more, you can download the repository. Now I am gonna share some comparison between MVP and MVVM. MVP is another popular Android development architecture which denotes model view presenter. Model contains the business logic and presenter communicate with models and update the UI, also update the model. Basically, in MVP, presenter and view is tightly coupled. Here is some basic difference between MVP and MVVM. In MVP, observables are not needed as presentation layer in the architecture to display the user interface. In MVVM, observables are needed for each user interface components due to absence of presenter. MVP is a tight coupling between view and presenter, and the change in view affects the presenter's user interface. But MVVM, the view and the view models are not tightly coupled. In MVP, since the user interface is used more, many interfaces make the architecture heavy. In MVVM, there is no user interface, and hence fewer interfaces are used. The architecture is light when compared with the MVP. I hope you have enjoyed the overall session. If you have any question, please raise this question. Or after the summit, you can send me email or you can send me message in my LinkedIn. Thank you again for joining with me.
Okay, let's thank Ali for his presentation.